Hello, everyone. Welcome to another session of Microsoft Zero to Hero community. Today, we are going to have another session, live session with another experts and also on a very cool topic, which I really looking forward to hear and learn more about serverless environment and serverless technology from one of our experts. So we are in May, and also, as you know, our May calendar is on fire. And why? Because we are in MS Build weeks, and it's really great because it's a great opportunity for us to learn more. And with that said, our plan is having more sessions and providing more information and having more live sessions for you guys. So I don't want to spend a lot of time to talking about these things. So let's jump to the our slides as usual. So welcome to our sessions today about serverless everything with Ricardo Covo. We are happy to have him here with our session. Next slide. Okay, about Microsoft Learn. Have you joined us or Microsoft Learn community yet or not, no worries. You can find Microsoft Learn community information in aka.ms Microsoft Learn community. And this is the best place that you can learn and share about Microsoft technology, Azure, Microsoft Cloud, and so on. And it's a great Microsoft Learn hub that you can share as much as you can, and you can collaborate with other experts and also other learners, which can keep this learning circulation in around the Microsoft Learn community. So make sure that you join Microsoft Learn today, and also aka.ms/join Zero to Hero is Microsoft Zero to Hero community learning room, and it's a great place that we can have you and you have this opportunity to share your knowledge with the others. We are in the MS Build weeks, so make sure that you registered. And between 21st to 23rd of May, it's a great opportunity. So both in Seattle, in person or online, you can join and you can learn more. If you want to learn more about MS Build events, aka.ms Build is the place that you can learn more about MS Build. And the last slide here is about our code of conduct. So please be aware of the others, be friendly and patient, be welcome and respectful, be open all questions and viewpoints, be understanding of difference, and be kind of considerate to others. So now it's time to introduce Ricardo Covo here with us. Thank you so much. You are here with us, Ricardo, today.
Thank you. Thank you. I'm really excited and excited also about kicking off this month of learning, right? Like it's a packed month and I'm excited to be a part of it.
Yeah, great. And just for more information to our audiences, we normally have sessions at Saturdays, but because of the MS Build and our exclusive calendar, we are going to have 14 sessions in May calendar. So the first one is one of the best one, I guess, because we are talking about serverless everything, and it's really cool topic. So stage is yours.
All right. It's can you share my screen?
Yes,
All
and
right.
good luck.
Right. Perfect. So thank you. We're here to talk about serverless everything. This is something that I'm really passionate about. So hopefully I can inspire you to look into some of these services that are out there that not everybody know about and that it will make your life easier. Let me just go here and all right. So my name is Ricardo Covo and I'm a principal consultant for app dev and modernization at CenturyLogic. My main social media is going to be LinkedIn, so feel free to reach out and connect there if you want to keep that conversation going. Before CenturyLogic, I was a cloud solution architect at Microsoft Canada. And before that, I was really into development and agile coaching for several years. So let's go and have some fun. A little bit of my story. Like, this is me kind of when I'm creating. Like, I love developing new things, creating new things. It gives me joy. This is created with Mid Journey. Um, be aware that these tools will take a lot of your time because they're so fun to use. Um, this is me thinking about infrastructure. It's really, for me, it's not the greatest. I know it's needed. So I have friends that are very good at it. For me, I'm more on the developer side, which kind of aligns with all um, the serverless advantages in terms of ease of use and whatnot. So today we're gonna this is the agenda. We're gonna talk a little bit about serverless, and then we're gonna run through some scenarios. I'm gonna be switching between the presentation and the portal, and maybe some IDEs. Um, so um, so that's the idea, and then talk a little bit of other services that make everything better, and you'll see where I'm going with that. All right, so thinking serverless and thinking about the evolution of computing, we have gone from having physical servers all the way to serverless, and the evolution has been not it became very fast at the end part of it, but what we're doing here is adding more and more levels of abstraction for the physical server and focusing more on the business logic, which is basically what adds a lot of value to organizations. When I think serverless, there's three main things that I'm thinking about. No infrastructure management, so not having to select the size of my servers or what type of operating system. I just want to deploy my code and or my configuration and be done with it. Normally, it's um, serverless means that it's instant and it's event-driven scalability. So I don't need to worry about the scaling out and in. I am more interested on just doing my code, and I trust that the platform is going to do that for me. And the other thing is consumption. Like, I want to pay per use, um, and yeah, that I think that makes it normally, depending of the services that you're using, you're gonna be um, charged per consumption. The consumption though means a little different if you're like a database or if you're a web service. So, but in any case, it is consumption based. So when we're thinking serverless, the first thing that comes to mind is Azure Functions. Azure Functions is where most of this got started, but little by little, there's other services that have been created. Logic Apps is a server has a consumption model. Cosmos DB is consumption model. Um, Azure SQL has a consumption model that you could use. Event grids for hooking into an event source. That is serverless APIM. Like a lot of architectures right now will have an API manager on front to kind of gate or create a facade over the backend services. Well, that can be used as serverless at this point. Container instances are a serverless service that allows you to run um, container images in a serverless mode. Static web apps will host your applications in a serverless model. Container apps is one of the most exciting services coming out lately, and it's basically serverless Kubernetes. So we're gonna in a lot of these we're gonna go into the portal and see how they're configured and how they work and some of the options that you get. But just by looking at this screen, you can probably already put services to to portions of your solution and understand that pretty much anything can be achieved with the serverless technologies that are out there today. So let's start with a very simple scenario. I know that there aren't a lot of production samples that are this simple, but in the very basics, you will have a user interface, a web API in the middle, and a database hosting or for storage of your data. Well, this in a very simple implementation could be a static web apps, let's say a React JavaScript application hosted on web apps with Azure functions running. That could be on Node.js or .NET or whatever, or Python or PowerShell, whatever technology you're more um, familiar with. And we're going to have a database, a NoSQL database, and those three components can be completely serverless. So let's start talking about what static web apps are. So these are basically it's a web hosting for static contents like HTML, CSS, JavaScript, and images. It is almost like a CDN for your web apps. It does work very well with static sites, but it will run things like React JS in Angular, Vue, with a little bit of server rendering. It does have an integrated API model where you can use functions directly from it, and it will be globally distributed by default and have free SSL certificates that are provided for you. So with that, I want to switch to the portal and show you what I'm talking about here. So I'm on my own um, subscription, and I'm gonna go into Zero to Hero demo. And if you haven't been in the portal for a while, you're gonna notice that they changed a little bit, like how they display things on the side. So now they're collapsible, the settings, cost management. It's taken a little bit to get used to, since I was able to click on things very quickly. Now I have to look for them. But that's a new thing that is going on. And here I can see that I have my static web app is hosted in East US. So I'm going to go into it and show you a little bit of the options that you have. So right off the bat, I can see that it has a URL. It is being deploy from my GitHub account. This is a static website using Elementy, and it basically compiles and deploys the static site. I'm on the um, free SKU, but you could do the others. But in here, in your configuration, there's cool information that I want you to be aware of. So I can set up my custom domains, or I can do a connection with functions that are already deployed on 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 my uh, on my subscription. I could set up database connections. Very importantly, like I can have multiple environments. So right now I only have a production environment, but I could add a preview environment and then maybe do some traffic splitting, kind of do A/B, similar to the slots on app service, but not exactly the same. And then, yeah, I could select to upgrade to another plan where it's more standard, but I'll have to pay. It's still not a ton of money to pay. So what I've done here is deploy my personal website into this new um, static web app, and you can see that it runs really, really fast. They kind of just threw it at me, and all of this is being deployed from GitHub. So that's a little bit about static web apps. Again, the way that I think about this is a CDN for my web apps. It is globally distributed and very, very fast to serve content. All right, so that's a static web apps. So that was, if I go back a little bit, that would be like my user interface. It's being deployed to that service. So the next one, it's a biggie, right? It's Azure Functions, and it's basically little pieces of code that have a single responsibility. They're normally short-lived, and they're event-driven and scalable. So imagine normally the things to consider on Azure Functions are triggers. So what is making this piece of functionality work? Inputs. So what are automatic inputs I want to put into my functions? And this could be provided by the user. So in an HTTP, for example, it would be the body of the request. But it could also be um, other type of inputs like reading from a database or reading or reading from a storage account. And then there's so that's what is called, well, there are triggers, there's input bindings, and then there's output bindings. And a very common scenario is you're reading an HTTP request and have an output binding that is a message on a queue. So those are things that you can really do quickly with functions. Um, Normally, functions will scale on their own depending on the number of requests or the number of um, messages on a queue. They will know to scale, and that's one of the benefits, not having to worry about that. Now, there's an asterisk here on stateless because normally there are stateless, and in general, you want to keep them very, very short and to the point. So no state necessary, but there is a variation which is durable functions. It's an extension of functions, but let you have stateful functions. So for example, if you were going to implement a fan out, fan in kind of pattern, you would start with an orchestrator and then fire the three or more functions that you want to fan out and wait in a specific pattern for them to come back and then finish. So it is a possibility. There's many patterns that are enabled by durable functions. So Azure Functions have their own type of project on a project template like on Visual Studio, for example. And normally here, if it's a process queue worker, what I would do is have a function, and then the service bus will be the trigger. And then whatever I do, this is how you would professionally work on functions. You would work and have it source controlled, build and deployed. Their function, their templates that are made for you that you can use. When you select to create a new function, it will ask you about what type of function you want. Do you want an HTTP trigger, a timer trigger, a Cosmos DB trigger? So you have different type of triggers that will determine how your function is created. For example, if I create an HTTP one, it's gonna and there's gonna have the request as an input, right? But the best way to demo this is directly in the portal. So I'm gonna go here, but please, this is not meant for you to develop your production code on the cloud. It's just easy to demo. So I go into the function app that I previously created, and let's wait for it to load up. And you can see in here that it is trying to get what functions I already have. I don't have any, so I'm not sure why it's taking so long. Oh, but, yeah, so I'm gonna create a function, and I'm gonna do the simplest one. I don't know, there's some interesting errors there. So I'm gonna create a demo 0 to hero. It's a function. The authorization level is who can access it. You'll have like a token that will allow you to access it, but I don't think I need to worry about that for now. All right, so I go into my function. So I haven't had to worry too much about infrastructure or how this is running. I just told it that I wanted to do .NET functions, and so I could come into the code and actually work in here and play. So again, if you're gonna do this in a professional way, you would do it on Visual Studio or VS Code, then build it and deploy. But because I'm doing the demo, this is a little bit of how it will look. It is reading the request and doing something with it. I could test it from here and see that it's running and play with input parameters and whatnot. This one receives a body and it is using the host key, and um, there you go. It's just saying hello Azure because that was the input. Azure 0 to hero. So Azure 0 to hero, you can see the logs would have been very active during those times. But the reason I think it's a good idea to demo from here because they have this visual integration point that allows you to see, well, what were your triggers and inputs? We know that it's an HTTP trigger. I could add separate inputs though, and the inputs can come from many places, storage account. So this is a blob storage. So this is the input binding, could be table storage or SQL input binding. So any of these you could use. And you could also come here and the function is your code, but then you can determine the outputs. So we know there is an HTTP response, but I could add other outputs. And the outputs could be writing a file in a blob storage, or it could be writing a message on a queue. So here are some of the most um, common output bindings. Something really cool that they added recently was that you can have different types of. Um, so when you create it from here, you can see more types of triggers. Like you can see HTTP trigger, timer trigger, but then there is a send grid. So this one actually has all the plumbing to go and send emails when an event happens. There's durable functions, templates as well, or even if you're using RabbitMQ, there is now a binding for that as well. So that is about functions. Normally, you wouldn't do like your whole API service just with functions. If it's something that needs to be up 24/7, maybe other services are better. But if it's something that is responding to requests, in the requests are short and single responsibility by nature, then this is a very good service to consider. From my experience, Azure Functions are now a staple of pretty much every architecture that I see out there. Normally, an application will have like a whole ecosystem of little processes that are helping the main application, and some of those are very, very fitting for Azure Functions. The other service that we saw on that initial diagram was the database, and Cosmos DB is a NoSQL database or the document database offered by Azure, and it has one of the highest SLAs that I ever seen. So it has na- 5 nines of SLAs, which is pretty impressive. It can also be globally geolocated, and it has a guaranteed in speed and scale. So if you haven't used NoSQL or document databases before, this will feel a little bit strange, but it is fit for a lot of architectures and solutions. Um, and when you create it, one of the great things about Cosmos DB is that you can interact with it with many interfaces. So let me go back to the portal. I did create one, but I want to show you when you go and create. Um, I'm gonna go and search for Cosmos DB. When I go and create Azure Cosmos DB, one of the first questions is, hey, how do you want to interact with this database? NoSQL allows you to do like SQL, familiar SQL query on your document database. But if you were more familiar with MongoDB before, you could actually use Cosmos DB, but use the MongoDB API. Even Postgres has become an API that you can put in front of Cosmos DB. So it supports things like Gremlin and Cassandra as well. So I'm gonna go into the one that I already created, and it's a Cosmos DB account. And um, basically, it's a data server, and you will create containers inside of it, and inside of those you can create documents. So if I go to Data Explorer, I probably have nothing. Dun, dun, dun. No, I don't want to do that right now. So I'm gonna go and add a container. Okay, so this is extremely slow. So some of the settings that you have available here, it's what kind of consistency do you want? Um, what backup and restore options, course, because you access this basically um, as an API. In the way that the consumption is measured here is with RU, so read units, and it's basically that's how they're measuring how much you're consuming. So I'm gonna create a new container here, but before a container, I need to create a database. So, and then the container ID will be just demo. Then there's a lot of things about managing the database itself. You normally want a partition key. So I'll just say demo ID and what unique keys, etc. And then you basically use it as a database. Inside of that container, you can create documents and whatnot. So let's see. Did it create it? Mm, All right, so I'm not sure if it created it or not, but basically this is you will access it through an API. There's an endpoint, and then you have your primary keys. One of the other things that you could look into is how it integrates into other data services. And so these are the containers that I have. Let's see if now it shows. I think I didn't successfully create one, but I'll move along since the concept of a database is probably very common. All of these services are being created in a consumption model. So I want to take a very small detour and talk to you about the Azure Developer CLI. So it's basically an accelerator to stand up common scenarios. And this scenario right here is one that you could stand up. So maybe some things to take note here is the Azure Dev. So the Azure Developer CLI, it basically allows you to create reproducible scenarios. And one of them is, for example, this one is a to-do site that's running under Node.js with Mongo, Cosmos DB, and static web app and functions. So there is very little that you need to do to get this up and running. So basically, you just first initiate the template and then just do Azure up. You need to be logged in into your subscription, but this will provision and deploy to Azure. Now, if anything else, I use this for a lot of learning. For example, I set up this early and it tells me, okay, for this, you need this infrastructure, and it shows me all the bicep that is necessary. So I don't worry too much about the code itself. I just want to know about the best practices that are included in here. But it also creates all these resources on Azure, so it gives me like a leg up to go and learn. Now, when I started playing with this, they were only the Microsoft uh, samples, but now they've opened it to the community in a way that people have been creating their own scenarios. So if you want to see, hey, how would I kickstart like Azure Search, OpenAI, and JavaScript project, you could go ahead and initiate a template and deploy it, and you will be up and running. And from that point forward, you just modify the code that started. It's like the templates on Visual Studio. It's just that includes all the bicep or Terraform. Some of them are in Terraform. Uh, um, it will include everything that you need to move forward. All right, so this is kind of like what I got from it. It includes source, test, infra. Some of the assets are just images. So it is a good learning tool for sure. So that is Azure Developer CLI, ASD, and then you can see all the templates. I think they have a link there. Right, so if we want to do the same scenario but different technologies, we could do an Azure container app, and we could deploy our web application into one container and our web API into a separate container. and still communicate with Cosmos DB. There is a template for that. It's called Container as Cosmos DB, and there will be the one for Node.js or the one for .NET. Um, so what are container apps really? So serverless container for me is Kubernetes, but serverless. Now, when to use container apps against Kubernetes? So the number one question is, do you need access to the Kubernetes API? Like if you need to that low level configuration, then um, then you need to remain with Kubernetes. But if maybe your organization is not ready to take on all the configuration that is necessary for a whole Kubernetes cluster, this is a good option for your containers. It uses standard open source tools like Kubernetes, Kata, and Dapper. Envoy is used for the ingress, Kata for the scalability. Kubernetes is the base for everything, and Dapper is supported for your sidecars. Um, so normally a container app environment, how it works, it's similar to if you're familiar with app services, you have an app service plan, and within it, you can have multiple applications. In here is the same. The container app environment is is where you would deploy your applications into. There are two type of applications that you can run: applications or jobs. And there is a very nice table that tells you what which ones are what. But an application will be something like an API that needs to be up like 24/7 or whatnot. A job is something that runs and finishes and then is done. Um, so both of those are supported. The jobs can be triggered by things like an event queue. And one of the good things about container apps is that you pay by consumption, but also they allow you to go uh, into into zero instances, which means that you don't pay anything if nothing is running. So I do have a configuration, a deployment of container apps already that I've done for other demos. So let me just go to that resource group. Uh, Demo. So you can see here that I have one container apps environment, and then I have a container app and then a container app job. So I'm going to go into the environment first. So this is the high level container. It has its own API, IP, I mean. And it has certain settings. You can put it up here certificates or your Dapper, reusable Dapper components. You can have a custom DNS, set up MLTS, all of this at the high level. But then when you go into the application itself, you're going to start seeing something that if you're familiar with Kubernetes, it makes a little bit more sense to you. So for example, on your application, you can see the revisions and replicas, um, and the scalability of of the scalability configuration. You can see here I can go from 0 to 10. Some of the other things that you will be familiar with are secrets and ingress configuration. In this case, I have continuous deployment from my GitHub. I think, let me see. Oh no, from a container registry. Um, but that's how you would set up, let's say, an API. So I have it set up to go from my container registry in here. You get automatically an application URL, but you can set up your custom domain if you want. This gets a little, so here it is. It's gonna, I haven't run it today, so it's probably a cold wake up for it, but it's basically there and running. Then if I go into what my, let's just go into the environment, and I go into applications. Now the container app job has a little bit different and more and simpler configuration. I still have like what the container had and secrets, but there's no ingress because it's not necessary here. One of the things that I like seeing, and again, so the execution history, um, you will see that it has run 2 times. I can probably come here and rerun it. And all of this can be done programmatically as well. There is CLI or HTTP requests that you can do to automatically to automate that. But it basically goes and runs whatever the container is. So this one is right now running. So container apps, very like, a lot of people are not ready for Kubernetes, but want to steal the benefits of using containers. This is a great service to run in your containers with a lot of power and not that much configuration. Now, so all of that, like a more realistic scenario is that you have a static web app that is actually talking to an API management. The API management might route or will route that request to different services according to the need of the application. So for example, if it's a job intake, imagine like a request response kind of a pattern that you're going to do in a distributed architecture. You may have a function that gets the HTTP request and sets up a queue somewhere. Um, but if it's an API that needs to be up and running like all the time and is used by the application in every page, maybe multiple times per page, maybe your API should be on a container app. In the backend, you may see another function responding to whatever the service bus message requested. You could also say that the API is reading the Cosmos DB. Now, every time that you write into the Cosmos DB, an event gets triggered, and you can subscribe to that event. So maybe you use Event Grid for that and use a logic app to process something, maybe notify something, create a log somewhere. So logic apps, we're going to see a little bit about them, but they basically have the benefit of having hundreds and hundreds of connectors that will allow you to to do very powerful processes with little to no code. So logic apps is low code, no code kind of solution. So API management in Azure, we simply call it APIM, allows you to be that facade between the front end and back end. You can define a very standard set of rules in the point of ingress for authentication, authorizations, etc. And for developers, it actually creates a developer portal that allows them to navigate and learn about the APIs that are exposed through APIM. So the APIM components normally includes the gateway, which is what developers would use or programs would use to reach out to reach the functionality of the APIs. There is a management plane, which is where you configure how certain endpoints behave. And then there's a developer portal, which is where people will read documentation and even test, try out the APIs. I was thinking that unfortunately I don't think I have something up and running for APIM, but basically I will show you how I would create it. So if I go to this demo, I could go create, say here APIM, API management, so there's no confusion. And I can go in here and say create. Give it some name. So your organization and your email, but in here, when you're selecting the pricing tier, you will go to consumption. And then from that point forward, you can configure your APIM accordingly. So Logic Apps is a different dev experience. It's a low code, no code. It works similar to functions in the sense that it's triggered by something. It could be a request, an event, or a timer. But then instead of code, you have a set of controls and actions that allow you to do processing. Um, has a very strong connector ecosystem, which makes it very, very appealing. So I think you could develop on VS Code or Visual Studio, but what I'm gonna do is show it to you on the portal. I'm gonna go back here and go to zero to hero. So what I did yesterday is create a Logic app. When I go in there, I can go into the Logic app designer, and it is taking a little bit. I think there is something between StreamYard and Azure kind of competing for resources here. All right, so in my case, I have already set up a trigger. Oops. I set up a trigger of an HTTP and I set up a response. But in the middle, I can decide add an action or a parallel branch, but let's just say I'm gonna add an action, and I can do a ton of things here. Because of the zooming, you cannot see how many things are here available. But for example, I could go into Salesforce and well, these ones are by DocuSign. Let's see if Salesforce is available. So Salesforce has their own connection. So for example, I could go and create records and create or get records. So I'm not going to do it, but basically when I add the action here, it's going to say, hey, well, where am I connecting? And I will need to sign in, and then it will give me a set of records that then I could manipulate and add to that response. So it's a lot of fun to work on Logic Apps. They're very, very powerful. So I encourage you to think about them when you're looking for a lot of integrations. So one use case that I implemented one was listen to Microsoft Defender events, and depending of what I'm getting, I would add a ticket into ServiceNow, for example. And that's something that took very little effort because the connectors already exist. So an example could look like this HTTP request, and then you can do parallel branches, and it integrates very easily to Azure Functions. It could also provide integration with APIM. It's very easy to work with, very complete as well. We're running out of time, but I'll slowly mention container instances as a serverless option for your containers. If you have scenarios where you need like a lot of power but for little time, like imagine rendering a video, something that could run for 2-4 hours. It's going to require a lot of resources, but once it's done, then it's a good idea to have a container instance that do that work. uh, Things that are like nightly processes that are going to run, um, they're similar to, it could be think of like jobs. So I would consider container instances in those instances. And if you need um, some of the features like Hyper-V, isolation, and security level, that's amazing for it. Now, in my architecture, I kind of shown event grids and service bus. So these are more PaaS services, but those are the little bit of PaaS that I need. I'm still not worrying about infrastructure, but it really enables my distributed architecture. So in Azure, the messaging options our service bus for queues and topics, event hubs for large ingestion like event ingestion and processing. And event grid, it's also ingestion and push style distribution of events, but it's really tied into Azure. So things that happen in Azure throw events that you can consume through event grid. So to complete the scenario, I would add some services for operations, including services that are part of Azure Monitor, Key Vault, Container Registry, and there's some supporting services that are offered as PaaS or SaaS that are gonna enhance or enrich your application, and they're still I consider them serverless because I don't need to think about servers. But a whole architecture, and I didn't have to select the size of anything or think about um, a lot of infrastructure concerns. Now keep your infrastructure buddy handy because there's some network configuration that is always needed, but as a developer you can focus on the business value and not on infrastructure. Now, with all these services, it's something important to notice that we're not longer thinking about is either A or B. We don't need to be tied up to one service or to one platform. We really want to think A plus B. Like I could use functions for this, but container apps for that, or container apps for this, um, and Kubernetes for that. So pick the right tool for the right job, and don't be stuck on thinking that everything needs to go one way or another. With that, I think I've covered all that I wanted to cover. We went from very simple architectures with three type of services to actually exploring most of the serverless services that are available for you. And I really hope that this has inspired you in a way to look into the services, to think about them, and have some fun. That's it from my side, Said. I'm not sure if you have some parting words. Like I can't hear you. I see you speaking, but maybe you're on mute.
Can you hear me now?
Yes, you're
Yeah,
back.
perfect. Yeah, let me tell you what happened in the behind the scene. I don't know what happened for my camera, but it start buzzing and disconnected, and all of my devices start, not
Oh,
working.
good
Yeah,
good thing you were not doing the the presentation. That would have been bad.
yeah. Imagine that. Yeah, but yeah, thanks so much for the my Surface camera. So yeah, I was telling that it was really great because one thing that I loved about your presentation was related to not only connection between services and serverless things, but also the things that we can leverage all of these services together to be able to create integration and automation with all these resources together in Azure. So it was really great. It was really great.
Right. It's really good when you see it all coming together, right?
Yeah, exactly, exactly. Actually, we have a question here. Let me check from Vincent.
Yes. So yes, there is a way for data streaming. I don't have so I'm pretty sure if you do a quick search, you will find it. But if not, let's reach out to me in LinkedIn, and I'll help you find some examples.
Yeah, great, great. And also we have some comment from the others. Lisa, she said thank you. And also Peria from Ricardo, and also Gisel, if I spell it
Giselle.
correctly. Gisel,
Yeah.
yeah. Yeah, perfect. Thank you. We normally have a kind of challenge for our session. So, best question will receive a 50% exam voucher of Microsoft Fundamental Exams. So, since
Nice.
we have only one question, I think it goes to Vincent.
Vicente.
Yeah. Okay, perfect. We will contact you, Vicente, and we will send you these exam voucher. Again, thank you so much, Ricardo. It was really great, and we learned a lot from you.
I'm glad to be here anytime.
Yeah, amazing. Perfect. Don't miss our next session, which is going to start in 1 minute. So if you haven't joined or registered yet, make sure that you registered. Also, it's available on YouTube and LinkedIn channel of Microsoft Zero to Hero. Hope to see you again soon. Thank you so much. Wish a great morning, afternoon, and also evening.
All right.
Bye.
Bye.